All right, so I want to revisit a concept we talked about before, which was systems of linear equations. And we solved them by writing them both down, solving for one variable, plugging in that variable into another, and then solving for the other variable. So we had things like y equals 2x plus 5, and then something like y equals 3x minus 4. Okay, so now we have the two variables x and y. So how did we solve them before? Well, here what I did was I made it easy right now. I had already solved for y, so I could plug in this y here. So now we have 2x plus 5 equals 3x minus 4. This is from this y, and this line is from this y. Okay, if they're equal, then we can go and simplify. So what I want to do is bring this 2x on, subtract 2x on both sides. So then we have 5 equals, this becomes 1x or x minus 4. Then add 4 on both sides, so we get x equals 9. X equals 9 is part of the solution. So we have part of the solution to this system of linear equations. So 9. Now we need the y value. Let's plug in that 9 in either equation. How about the second one? So we have y equals 3 times 9 minus 4. Well, 3 times 9 is 27 minus 4 is y equals 23. So y equals 23. And so the solution set is 9 comma 23. And you can check and see that that works. But then what does this mean graphically? We have two lines and we found a solution. Well, what that means graphically is that the two lines intersected. So I'm going to draw an arbitrary two lines. I'll draw it here. Sorry, I'll draw it right here. So here are two arbitrary lines. So we have x and y, and I'll label the first line as A, and the second line as B. Okay, great. They're definitely not parallel, but we have this point here where they intersect, where they touch, and that point here is the solution set. Why? Because on a line, every single point here is on this B line, which means that every single point satisfies that B equation. And every single point on the A line satisfies that equation. So if you find where they intersect, that point satisfies both equations. And isn't that what we had before? This point 9 comma 23 satisfies both of these equations here. Okay, so now I'm graphing both of these equations, or another two lines, and then this point will satisfy both of those equations. So that's how you solve a system of linear equations graphically. You graph them and find where that point is. So these could be any two arbitrary lines, and once you find where they intersect, that would be the point. So let's say this point is 2 comma 0. That would be the solution set. And now I want to do something similar, which is systems of inequalities. Systems of inequalities. Now, these are very similar because we're talking about linear functions, but now we're talking about inequalities. So instead of an equal sign, we'll have one of those symbols, like less than or equal, greater than or equal, and so on. So if we're given two inequalities like y is less than or equal to 1/3 x plus 3, and y is greater than or equal to negative 2x minus 4, then we can still find the solution set, but it'll be a whole bunch of solutions because y less than something or y greater than something corresponds to a region. So let's see why that is. So let's graph y equals 1/3 x plus 3. So if we graph that one, we have, here's our x, y. So we have a y-intercept of 3. And we're going to move up 1 across 3 because the slope is 1/3. So up 1 across 3, up 1 across 3. And this is our line. Okay, our line for the first one is this one right here. So this line is y equals 1/3 x plus 3. That's what it equals, but we're still talking about an inequality. But let's just graph the line as if these inequalities were equal signs, just so we can graph it. So the next one is negative 2x minus 4, so that's the y-intercept of negative 4. And then we go down 2 across 1, so to the right one. So down 2 and over 1 down 2, and over 1, and so on. And I'll do this in blue. So then we have this line here, which is y equals negative 2x minus 4. All right, so now we have these two lines. But look at the inequality. They want the point that satisfies both of these inequalities. The first one says y is less than. So what that means is we need to go to that line and see what y values are less than this line. Well, the y values that are less than this line are all these y values down here, right? Because if we're at this y value is less than that. If we're at this y value, these y values are less than that, and so on. So all the y values that are less are below it. So let's graph that. What I mean is, like, let's shade it in. Let's shade in that region that's less than this y, and we'll shade it in blue. Or we'll shade it in red since the line is red. So we have this. This is the whole region where y is less than 1/3 x plus 3. And now we can do it similarly with the blue line, which is y equals negative 2x minus 4. But instead of equal sign, it's y is greater than or equal to, okay? So we have an equal sign already, but now we need to shade in the region that's greater than or equal to that blue line. So similarly, we're going to do a shade in, but it's going to be greater than. All right, and I'll make it a bit thicker so we have everything above. You see, now we have everything above the blue line. And so now the solution set is what satisfies both regions. So the region that satisfies both is where they intersect or where they overlap. And the red shading with the blue shading, they overlap where? Well, they overlap in this middle part, of course. That's where the shadings are both the same. That's where you see blue shadings and red shadings. So it's within this region that I'm going to call R, that we find the solution. Okay, R stands for region, and this region is the solution set. And so for inequalities, you don't get 1 point or 2 points. You get infinite number of points. You get a region. And so this black region can go on forever because the lines go on forever. But at least we have an area that satisfies these two inequalities. So again, to review, graph out the inequalities as if they were just equal signs. And then once you do that, look at what it's saying. Is it less than or equal to? If it is, then you find y values that are less than, and you shade it in. And the same for greater than. And then to find the solution, you find where they intersect. And just keep an eye out. If it's greater than or equal to or less than or equal to, you draw solid lines. But if they ever give you something that is an inequality with just a greater than sign or a less than sign, you draw dotted lines instead, okay? And all the dotted lines represent is that the points will never be on the line because it's either less than or greater than, not equal to. So remember, dotted lines if it's a greater than or equal to sign, and solid lines if it's greater than or equal to or less than or equal to. Alright, so now that we played around with lines a bit, I want to talk about parabolas. And parabolas correspond to quadratic equations, which we've already worked with. We've found how to find the roots, factor, use a quadratic formula, and all of that. But how do we graph quadratic equations? Well, first of all, they're going to look like this form. All right, so we know what lines look like. Quadratic equations look like parabolas, or they are parabolas, and parabolas look like this. So they have a curve up, and that goes infinitely up, or it could be a downward parabola, okay? So this is what's known as a downward parabola, and the left one is known as an upward parabola, as it's facing up. In other words, this can hold water if you spilled water in here, and this would spill water, so it's downward. And that's a good way of thinking of it. So when you're given a parabola, there are certain properties you need to know. And we'll learn how to graph that in a second. But this point here, when the parabola is upward, this point is the lowest point. It's the lowest point on the graph. So we call this the minimum. There's no point lower. Okay, every other point is getting bigger or getting higher. And then when you have a parabola that is concave down or downward, then this is downward, then what about that middle point there? Downward. What about this middle point here? What is that called? Well, that is the highest point. So that is called the maximum. All right, that's maximum. And I just spelled minimum wrong. Hold on. So this is minimum. Okay, great. So minimum and maximum. And those are two key ideas that we need to know. And in other words, the minimum, maximum, we can also call them vertex. Okay, a minimum is a vertex. They're vertices. So that's a vertex, and this is a vertex. And we're going to use a formula to find that point. All the vertex is a point. It's going to be x comma y. It's going to be x comma y, and we need to find that. All right. And the other thing I want to go over for parabolas before we start graphing them is that when you have a parabola, how do you know if it's upward or downward? Well, let's go back to the equation of a parabola, the general form. It's y equals ax squared plus bx plus c. We look at the a, the coefficient in front of the highest power, which is x squared. If a is bigger than 0, then we have an upward parabola. If a is less than 0, then we have a downward parabola. So downward. All right. So now that we know which way it will face by determining what a is, and we know the minimum and maximum, and we're going to find out how to find it, we can actually start graphing. Okay? So that's what we have here. Now let's actually start graphing quadratic equations. So I'll take a look at one of them. Let's try this out. Y equals x squared minus 5x plus 6. Okay, so the first step to graph would be to draw the coordinate plane. So draw coordinate plane, and that's pretty obvious. And then you should find the roots. Find the roots, which you know how to do, either by using the quadratic formula or factoring. Then after that, determine vertex. Determine the vertex. And the vertex will be an x value, so x equals something. And then you want to get the point, okay? So once you get that x, plug it into f of x, so f of x will equal y. And remember, y is equal to f of x. All I'm saying is once you get x, plug it into this equation so you get y. So then the vertex point would be x comma y, so that you can find that minimum or maximum. So remember, this vertex will be either a minimum, I'll write min, or a maximum max. After you do that, then you must determine if it's upward. So I'll determine upward or not. Or not. Alright? And then once you determine the shape, which is upward or downward, you need to start graphing. Okay? So then we need to start graphing. And to graph, you would graph the roots first. Graph roots, which are just those x values, the x values that make y equal to 0, graph roots, and then we're going to find the vertex or graph the vertex, and then we're going to draw a sketch depending on upward or downward, and that's pretty much it, and then refine it if we need to. Okay, great, so let's take a look. So first thing, draw a coordinate plane. I'm going to keep on referring back to this. So let's see if I can zoom out. I might be able to. Yes, I can. Okay, great. So let's draw a coordinate plane. So number 1, draw the coordinate plane. Did that here. And so we have x and y. All right. Now find the roots. You should know how to do this, so let's find the roots. What we do have is, I'll draw it right here. Actually, let's make that thinner. I have it right here. Y equals x squared minus 5x plus 6. Can we factor this? Yes, we can. Use the methods I showed you before. You would factor it as x minus 2 and x plus 3. Actually, x minus 2 and x minus 3. Why? Why is x minus 3 and x minus 2? Because minus 2 times minus 3 equals 6, and negative 2 plus negative 3 equals negative 5. So that's our factor. And remember, to find the roots, we set it equal to 0. So then what values of x makes it 0? X equals 2 and x equals 3. Great, those are our roots. So we did 1 and we did 2. Next, determine the vertex. And this is where we use the vertex equation or vertex formula. So the vertex formula for this general form of a quadratic, which again is y equals ax squared plus bx plus c, which you should memorize. To find the vertex, you would use this formula. So x is going to equal x, oh, that is way too big, hold on. X equals minus b over 2a. So wherever that point is, like if the point is here, that x coordinate of that point would be minus b over 2a. So now we need to find what minus b over 2a is. So what is b? B is equal to, in this case, b is equal to negative 5. So b is equal to negative 5, and a is equal to 1. Okay, so minus b over 2a, x would equal 5 over 2 times a, which is 2. So the x-coordinate of the vertex is 5 over 2. But we actually want a point. So if the x-coordinate is 5 over 2, how do we find the y-coordinate? Well, we plug it into the equation. So if we plug in 5 over 2 into y equals x squared minus 5x plus 6, what do we get? So I'll do that here. Y equals y equals 5 over 2 squared minus 5 times 5 over 2 plus 6. And so what does that equal? Once you do the math, you'll get that y equals negative 1/4. So our vertex now is x comma y, or 5 over 2 comma negative 1 over 4. Okay, so let me write this somewhere, all the things that we have. We have the roots. The roots are x equals 3 and x equals 2. We have the vertex is 5 over 2 and negative 1 over 4. And now what is the next step? The next step is, let's see, to find what? Determine upward or not, okay? So we determine that by seeing is a greater than 0 or less than 0. Well, here a is just 1, all right? So then a is bigger than 0. So since a is greater than 0, this is upward, an upward parabola. So we have the roots, we have the vertex, and we have the shape, which is upward. Anything else? Yes, now we need to graph. So I'll actually bring this over here, so I'll make it bigger. We have x, y. Don't forget to always write the arrows. Draw the arrows. Okay, so first thing we do, graph the roots. Here's 0, 0. Where is x equals 3? Well, we can draw it here. X equals 3 is here, and x equals 2 is here. Okay, so here are our two roots, one here and one here. Now, where's our vertex? That's 5 over 2, comma, negative 1 over 4. So we have 5 over 2. What is 5 over 2? That is 2.5. So great, it's smack in the middle here. And where's negative 1/4? That would be somewhere around here. So we're going to draw it right there. And so that's the vertex. I'll make the vertex blue, actually. And the two roots are black. So great, we have the vertex and the two roots. Now, do we go downward or upward? Upward, because a is bigger than 0. So we just start sketching, which means go like this. Remember, the parabola has to hit everything, the roots and the vertex. So there we go. That's it. All we're doing is making a sketch. It doesn't have to be perfect. So this is our parabola, and we just write the equation, which is y equals x squared minus 5x plus 6, and there we go. We graphed it. Awesome. And then using this parabola, we can find other points. Like if I say, tell me what the y value is if x is equal to 3. So if x equals to 3, where is that on the parabola? Well, we would plug it in. We would have 3 squared minus 5 times 3 plus 6, and that would equal y equals 9 minus 15 plus 6. And what would that be? That would be 0. Why? Because 3 is a root, remember. So then if it's a root, then y equals 0. So actually this should be 0, sorry. So if x equals 3, y is 0 because x is a root. All right, great. Now that we went over parabolas, I want to go over one more type of equation or graph, and those are circles. Yes, you can graph circles. So let's look at one circle. What is the general form? We know what a circle looks like, so I'm going to draw it here where the center is at the origin, and I'll label the origin O. Okay, so the origin is there, and the circle, I'm going to have a radius of 1 all across. Remember that a circle, all radii are equal, and so I'm going to draw that circle now. Nothing is perfect. Okay, great. So here's our circle, and it's going to be y equals something. We're going to figure that out. But what do we know about this circle? We know that the radius is 1 because I just drew it like that. So r equals 1. We know that the center is 0, 0. That's good to know. And do we know anything else? Well, we know the diameter because we know the radius. And we know one other thing. We know that for a certain x value, there are two y values. Why? Let's pick this x value here. How many y values correspond to it? Well, one here and one here. If you remember, to be a function, for every x value, you should only have one y value, but you have two here. So if x were 1 here, it would be like you have the coordinate point 1, 3 and 1, -3. So those are 2 points for the same input. So this circle is not a function. And a way you can test if something is not a function is by giving it the vertical line test. All the vertical line test does is tests if a shape or graph is a function, and all you need to do is draw a vertical line. So draw a vertical line through many points on the graph, and if the line hits in more or hits in more than one place or more than one point, it is not a function. So let's do the vertical line test. If the lines hit in more than one point, it is not a function. Let's draw a vertical line. If we drew one here, how many points does it hit? Well, one here and one here, not a vertical line. Same thing if we drew it here and here, okay? So this circle is not a function, but that's okay, we can still graph it. So how do we graph it? Well, we know the radius is 1, and we know the center is 0, 0. To graph a circle, we use this general form. This general form is y, or actually it's not y equals, you could put it in that form, but the way we're going to write it is x minus a squared plus y minus b squared equals r squared. R is the radius, and let's go over what the rest are. But this is a circle equation. This is a general form, which means that any circle you graph will be in this form. This is all you need. So r is the radius, as we know, and a comma b, that is the center point. That's why it was so important to label the center, and that's all you need. So our radius is 1 and our center is 0, 0. So we have x minus 0 squared plus y minus 0 squared equals 1 squared. So we have x squared plus y squared equals 1. And that is our equation. So I'll write it here. Equation of this circle is x squared plus y squared equals 1. As simple as that. And you can see that if you plug in a certain x value, you're going to get two y values, and you can try and solve it. You'll get a negative and positive for every version, and that's okay. But the point is, now we know how to graph circles. So let's graph another circle. How about this? What if I drew a circle with a center? I'm just going to tell you, a circle with a circle with center of 5, 3 and a diameter of 10. Okay, well, the things we need, radius and center. We have both. Center is a comma b, which is 5, 3, and the radius is half the diameter, of course, so that equals 5. See, that's all we need. So we have x minus 5 plus 3, plus y minus 3 squared both, don't forget that, equals r squared, or 25. And that is what it looks like, or that's the equation. And then if we were to graph it, we would see, well, the center is at 5, 3. 1, 2, 3, 4, 5. 1, 2, 3. Here's 5, 3. And then the center, that's the center, and the radius is 5. So we would have the radius as 5. So 1, 2, 3, 4, 5. It doesn't have to be exact, but you get the idea. It would be something like this. Here's the center, so we want to write that radius as all the way down there. So that's going to be the radius, so it'll be this huge circle there. The point is, it's going to have a center here at 5, 3, and it's going to have a radius of 5. And then the equation will look like this. X minus 5 squared plus y minus 3 squared equals radius squared, or equals 25. Alright, great. So we went over quite a bit how to graph a parabola, how to graph a circle, and also how to work with systems of linear equations and inequalities graphically. Great, guys. Alright, so let's go over some problems concerning parabolas and circles. Okay, so first one, what is the center of this circle below? And what is the radius? So the circle is x minus 3 squared plus y plus 5 squared equals 49. Number 2, write the equation of a downward parabola. So any downward parabola. So why don't you take a few minutes, pause the video, and try these problems. Alright, so since we're back, let's try number 1. So what is the center of the circle? Remember, the center is a comma b. So a comma b, which is something you get from the general equation, which is x minus a squared plus y minus b squared equals r squared. And so we need to compare a and b to the a and b we have up there. So here we have a negative 3, and we have a negative a here, so a equals 3. Here we have a negative b, or a minus b, and here we have a positive 5, so b equals minus 5. Another way of seeing it is you can say that negative a equals negative b, and negative b equals positive 5, and you still get b equals negative 5. Okay, great. So the center is 3, 5. And the radius, just for kicks, is 7 because the square root of 49 is 7. Okay, great. Actually, they did ask for the radius, so good. Good thing we found it. Alright, so now write the equation of a downward parabola. So downward parabola, the main part of this question to understand is that it will have an a value that is less than 0. And we know that the general form is y equals ax squared plus bx plus c. So we can pick a as negative 5, b as 3, and c as 6, let's say. So y equals negative 5x squared plus 3x plus 6, and that is our downward parabola.